Hello students, this is Dr. C. Sonia, Assistant Professor in Department of Chemistry, SNS College of Technology. Today we are going to see about the impact of atmospheric chemistry on air quality and climate change. Introduction. So what is atmospheric chemistry? It plays a very crucial role in shaping our environment. Chemical reaction in the atmosphere impact air quality and contribute to climate change. For example, industrial smog is produced primarily by the burning of the fossil fuels, which produces carbon dioxide from the complete combustion, carbon monoxide from partial combustion, sulfur, and mercury. The sulfur reacts with other chemicals in the atmosphere, producing several sulfur compounds, including the sulfur dioxide. Agriculture emissions like nitrogen oxide and ammonia forms particulate matter in the air which can penetrate deep into the respiratory system. So we are going to see what are the key concepts of these air pollution. That is, first is the air pollutants. Air pollutants like greenhouse gases. Greenhouse gases consist of carbon dioxide, methane, ozone, nitrous oxide, chlorofluorocarbons, and water vapor. And next is the aerosols. The aerosols are nothing but is a suspension of fine solid particles or the liquid droplets in the air or another gas. And next is the next key concept is the chemical reactions. That is, there are the chemical reactions that is taking place in the atmosphere. So ozone formation, the ozone is both beneficial and also it's harmful. There's two types. Okay. In the first step, the ultraviolet sunlight breaks apart in an oxygen molecule to form two separate oxygen atoms. In the second step, each atom then undergoes a binding collision with another oxygen molecule to form the ozone molecules. And the next chemical reaction is by the nitrogen oxides. So from vehicle emissions, power plants and industrial process, the nitrogen oxides are formed. And the third one is the air quality, the smog. So these smogs is the result of the photochemical reaction involving pollutants. So smog is formed mainly above the urban centers, is composed mainly of tropospheric ozone, primary, then next is the particulate matters, health hazards due to fine particles. This particulate matter such as the pollen and the dust, and the secondary particulate matters such as sulfur dioxides, volatile organic compounds, nitrogen oxides, and ammonia gas. So particulate matter is made up of solid particles and liquid droplets in the air. And next is the key concept is the climate change. So radiative forcing. The radiative forcing is the impact of the greenhouse gases on the Earth's energy balance. That is, actually, you have that energy balances. There is a difference in the balance, that is the solar radiation that is coming into the atmosphere and the infrared radiations that is getting out of the atmospheres. So radiative forcing is a measure of how the energy balance of the earth atmosphere system is influenced. Then next is the feedback loops. A feedback loop is a process which the outputs of a system are circled back and used as the inputs. It's actually by you are getting the output of any system. That is how far these measures that are taken from for to control the pollutions or or improve the quality of the air. You get a feedback of it. Then after that, you are going to get an output, and from the output, you're again that you using that output as a input. Okay, so that the next output what is coming out is to be is will be a better one. So you have some few case studies. That is Los Angeles smog. So Los Angeles smog, it is a very familiar and a very known air quality investigations. That is, they investigate the role of the atmospheric chemistry in creating smog. Los Angeles smog consists mainly of carbon dioxide, nitrogen oxides, and hydrocarbons. Contrary to the sulfurous smog, photochemical smog originates from exhaust fumes and industrial emissions. Los Angeles is surrounded by mountains which traps the volatile organic compounds and the nitrogen oxides in the valleys where people live and breathe. By the early 1940s, Los Angeles had all of the ingredients for the catastrophic smog events, which plagued the city for more than half a century. So, what is the solution for this? That is the emission controls, alternative fuels, and urban planning. So, Los Angeles smog is a very important air quality management case studies that is been known for many years. Stratosco- Stratospheric ozone depletion. So, this stratospheric ozone depletion is one more case studies. That is, they explore the impact of the chlorofluorocarbons in the ozone layer. So, gases like chlorofluorocarbons can deplete the ozone layer when they slowly rise into the stratosphere, are broken down by the strong ultraviolet radiation. They release the chlorine atom and then they react with the ozone molecules. So that is the mechanism of the formation, that is the destruction of the ozone molecules by the chlorine radicals. Okay, so what is the success stories over here is Montreal Protocol. So the Montreal Protocol, this is actually, it was finalized in 1987. It's a global agreement to protect the stratospheric ozone layer by phasing out the production and the consumption of the ozone depletion substances. That is, they are also mentioned as ODS. So ODS are the substances that were commonly used in the products such as refrigerators, air conditioners, fire extinguishers, and aerosols. So, by according to this protocol, the emission control, the emissions of these substances which affect the ozone layer, was taken into the that is into the action, so that the air quality will be improved. Then air pollutants in developing countries. So this is one of the major causes, that is, they analyze the chemical pollutants in densely populated areas. These chemicals pollutant agents in the environment are complex and diverse, mainly divided into metals such as the lead, mercury, cadmium, cobalt, and arsenic, and persistent organic pollutants, that is, such as the toxic organic gases, organic pesticides, polychlorinated biphenyl, and paint dyes. So, what are the strategies to control these air pollutants in the developing country is clean energy adoptions, public awareness, and policy changes. So here we can come to an conclusions, and understanding the atmospheric chemistry is vital for sustainable air quality and climate resilience. Thank you.